This is the second problem from activity 215. We're going to start by solving for the external forces. The external forces, remember, are either given, such as at joint A and C, or they will be provided by pins and rollers. E is a pin, so it has two forces perpendicular to each other. Its Y force is going to go up to oppose the force in A and C. Our X is going to either go to the right or left. I'm just going to pick a direction going to the right. If it's incorrect, once we calculate it, it will come out negative, so we have to switch the direction. D is a roller, so it only has one force and it's perpendicular to the surface. Since this is our surface, our D must go in the horizontal direction. Since we drew EX to the right, D has to go to the left. We pick a pivot point. Our pivot point is going to be E because it has the most unknown. We need to write a sum of moments equation, a sum of Fy equation, and a sum of Fx equation, and they all must equal to 0 because this is in static equilibrium. So we're going to start with the moments. Possible moments are at A, B, C, D, and E, and this must all equal to 0 or the truss will twist and bend and break. So we know we have a moment at A because there's a given force. There is no moment at B because there's no force given and it is not a pin or a roller. We have a moment at C because a given force of 500 pounds given, and we have a moment at D. We do have a moment at E, but since it is our pivot point, it will cancel out. Now I'm going to substitute in. So this is going to be FA dA plus FC dC plus FD dd. This is equal to 0. The force at A is 500 pounds. So for moments, the force and distance must be perpendicular to each other. So if I look at joint A, our force is downward, so perpendicular to that has to be to the right because that is where our pivot point is located, and that distance is 4 feet. If this is our pivot point and this is a bar with a force pushing it down, it will make the bar rotate counterclockwise, so this will be a positive value. Remember, counterclockwise by convention is positive, clockwise by convention is negative. So if I look at C, we have C here. Perpendicular is this distance to my pivot point. So that distance is 2 feet. So this is going to be 500 pounds. And this is going to be 2 feet. And if I push this force downward, it's also going to rotate counterclockwise. So it's a positive value. We don't know D because that's what we're looking for. So that's D. The distance of D, my pivot point is E. And for D, my force is going to the left. Perpendicular to that force is this vertical, which is 2 feet. This has to equal to 0. So if I look at this and I push this, my force is going to rotate in a clockwise direction. So this is a negative sign. Rearrange the equation, and so D is equal to 1,500 pounds. And our direction for D is correct because it came out positive. Now I'm going to write a sum of Fy. EY is going up, so I'm going to make it positive. A is going down, so it's minus A. C is going down, it's minus C. This is equal to 0. So EY is going to be A plus C, which is 500 pounds plus 500 pounds, which equals 1,000 pounds. And our direction is correct because it came out positive, it's going up. Sum of Fx is equal to EX is going to the right, so I'm going to make that positive. D is going to the left, so it's minus opposite direction. This has to equal to 0. EX is equal to D, and D was 1500, so EX is 1500, and since it came out positive, the direction of EX is in the right direction. So now that we found all the external forces, we're going to start with the internal forces. All I did was redraw the picture and labeled it with the correct external forces. So for the internal forces, you want to start with the joint that has the least amount of unknowns and the least amount of beams. That would be joint D. So I pick my joint and I draw my free body diagram. We know that D has to go to the left because we saw it going to the left. DE, we could draw it going up or down. It does not matter because there's no opposing force. So I'm just going to make it go up. And this is going to be DE. That means the beam DB, which goes horizontally, must go to the right to oppose D, because we already know D is going to the left. So this is my free body diagram for joint D. Unlike the external forces, when we do internal forces, we only do a sum of Fx and a sum of Fy. So my sum of Fy is going to be dE, which is equal to 0. So dE is equal to 0. Therefore, it is not a necessary beam, it's a wasted beam. So that could even be crossed out. Sum of Fx is equal to dB, going to the right, opposes D, which is going to the left, which is equal to 0. So dB equals to D, which equals to 1,500 pounds. And since it came out positive, I know my direction is correct and it is going to the right. So I'm going to draw my direction into the picture so I could keep track of it. I'm going to do is join E, because I can't really solve for C or A, and B I don't want to solve for because it has too many beams. So once I solve for E, I could solve for everything else. So first thing I'm going to do again is draw a free body diagram. Joint E. We already know EY goes up because we solved it. We know EX goes to the right because we solved it. Beam EC goes in the horizontal direction. Since EX is found to go to the right, EC must go to the left to oppose it. EB is a diagonal beam, so it could go northeast or it could go southwest. Since EY is going up north, EB must go to south to oppose it, so it's going to go southeast. Since EB is a vector at an angle, anything at an angle we must resolve into x and y using sine and cosine. So this is EB, this makes a right triangle, and this is theta. How do we find theta? So if I look up here, this is theta, and theta is opposite over adjacent. So if I look at this, this is tan theta, which is opposite over adjacent. This is 2 feet over 2 feet. So if I do the inverse tan, theta becomes 45 degrees. This is my vertical direction here. So this is going to be EBY, which is EB sine theta. This is EBX. So this is EB cosine theta, and my theta is 45. To help you out, I'm going to redraw the vectors. So if I redraw the vectors, this is EY, this is EX, this is EC, this is EBY, and then we have another one, EBX. In physics, we would never draw a free body diagram with the resolve component, but here, so now I'm going to write a sum of Fx and a sum of Fy. Sum of Fy, EY is going up, minus EBY, this is equal to 0. EBY equals to EY, and we're going to substitute into EBY, which is EB sine theta. So EB sine theta equals to EY. I'm going to divide both sides by sine theta. So EB equals EY over sine theta. EY was 1,000 pounds divided by sine 45, which equals to 1,414 pounds. And since it came out positive, I know my EB is going in the diagonal direction of southeast. Now I'm going to write a sum of fx equation. So EX is in the positive direction, so EX minus EC, which is in the negative, minus EBX equals to 0. So EC, if I rearrange this, is going to be EX minus EBX. And substitute in EX minus EBX is EB cosine theta. And now I'm going to plug in my numbers. EX we calculated as 1,500 pounds. Minus EB we just calculated as 1,414 cosine 45. This equals to 500 pounds. Since it came out positive, my direction is correct. It is going to the left. So now I'm going to draw in some of my directions. So we know that this beam does not count. We calculate EC going to the left. We calculated EB going to southeast. So the next joint we're going to cover is going to be joint C. We know that C is going to go downwards because it was given. So that means CB must go up to oppose it. We know that CE has to go to the right. The reason CE has to go to the right is because at joint E, EC went to the left. So they need to oppose each other or the beams will break or they twist. CA must go to the left because they have to oppose each other. So since everything is parallel or perpendicular, we do not have to resolve it into x and y. So now I could just write a sum of fx and a sum of fy. So sum of fy is going to be CB minus C equals to 0. CB is equal to C, which is equal to 500 pounds, which is equal to 500 pounds. And since it came out positive, my direction is correct. It is going up. My sum of fx is going to be CE to the right, so it's positive, minus CA to the left, which is negative, or it's equal to 0. So CA is equal to CE. And we calculated CE to equal to 500 pounds. And so our direction is correct. CA is to the left. So I'm going to label the drawing. So CE is going to be to the right. CA is going to be to the left. And CB is up. So now we're going to move to joint A. We know that to oppose CA, AC has to be to the right. We know that A is downward because it was given as downward. And we have a diagonal beam. The diagonal beam can be either northwest or southeast. Since A is going down, the diagonal beam must go up north. And it has to go northwest because it has to oppose AC, which is going to the east. So this is going to be AB. Since AB is at an angle, first thing I need to do is make it into x and y. This is AB, this is a right triangle, and this is my theta. And my theta again is going to be 45 because this theta and this theta are the same because this is 2 by 2. Opposite the theta is ABY. That's going to be AB sine theta. Adjacent or next to is ABX, and that's going to be AB cosine theta. I'm going to redraw the picture. So you have ABY going up, you have A going down, you have AC to the right, and you have AB x to the left. I'm going to write a sum of Fy, which is AB going up is positive, minus A, which is going down is negative. This is equal to 0. So ABY is equal to A. I'm going to substitute in for ABY, which is AB sine theta, which is equal to A. Divide both sides by sine theta, so AB is equal to A divided by sine theta, which is equal to 500 pounds divided by sine 45, which equals 707 pounds. Since it came out positive, my direction is correct. It is going northwest. At this point, I solve for every unknown. Since I did sum of Fy, I do not have to solve for sum of Fx. And then I don't have to do the last joint. So now I'm going to go in and put in the directions. So at joint A, AC will go to the right to oppose CA from joint C. We calculated AB going northwest. So at B, it's going to go southeast. And at B, my BC is going to go down, opposing joint C. My BE is going to go up to oppose joint E. And then my BD is going to go to the left to oppose DB. So if I look at beam AC, these are intentions. They're in tension because they're pulling away from the joint. CB, it is also in tension because they are pulling away. EB is also in tension because they're pulling away. BD is in compression because they're pushing into the joints. AB is also in compression because they are pushing into the joints. And CB are also in compression because they're pushing into the joints. Again, solve for the external forces by picking a pivot point and writing a sum of moment equation, sum of Fy and a sum of Fx all equal to 0. Internal forces, you start at each of the joints, draw your free body diagram, and you only have to write sum of Fx and sum of Fy. Keep track of your directions as you go along. If the value comes out negative, immediately change the direction so you make less errors.